let's go ahead and practice. You've got this on your Chapter 6 worksheet on the back in the second page. I'll pull mine up too. And this is a homework problem, so you're going to get slightly different numbers than what we see here, but at least we'll go through the process together, and it lets me show you how to do the Excel pieces. So the average number of acres burned by forest and range fires in a large county is 4,500 acres per year, with the standard deviation of 500 acres. The distribution of the number of acres burned is normal. So everything in the beginning of the story, you've got your pieces, and we just want to make sure we pull it out as needed. And you can see here it says normal, so think bell-shaped. And we're going to be working through these scenarios here, the same ones on your worksheet. And I'm just going to bring us over to each part. Let's do part A first. And on your worksheet in the step 1, it'll say, hey, what's the mean and standard deviation? So that's where we wanted to make sure we understood that the 4,500 acres per year and the standard deviation is 4,500 and the standard deviation is 500. So those are the two numbers we're going to be pulling out for our mu and our population standard deviation. So be aware, this symbol right here, the sigma symbol, that's the population standard deviation. So in part A, we're going to compute the probability that more than 5,000 acres will be burned in any year. So in this scenario right here, are we working with a greater than or less than scenario? And you can type it in the chat or say it out loud. And we know that because of the word more. So you're just looking for the clues so that we set it up as we need to in Excel. So we're doing a greater than scenario. And so the event of interest is going to be the probability that X is greater than 5,000, right? So we just want to also write it as a math statement. So everything should be consistent, nothing flip-flops, right? More, greater, and the greater than. So you want to stay consistent with whether you're writing it as a word, whether you're thinking about it as a math statement, as well as how we work it in Excel. So for the Excel piece, what we're going to be doing is looking at our curve here. And if we map where 5,000 falls, because if we know it's 500 acres out is one standard deviation, that means 500 out is right here at 5,000. And we're interested in this part of the curve here, over here on the right-hand side. So what you're really doing when we're finding the probability of something is we're finding the area under the curve. And it's not easy, like, like finding the area of a square or a box. That's why we have to use these formulas, and Excel will do that for us. So we're going to be focused on this side right here. And recall, we learned last week that Excel only knows how to read left to right. And so whenever we're doing a greater than scenario, our formula has to have that 1 minus at the beginning, right? So 1 just represents 100% of my curve, and I'm interested in this right side, so I have to get rid of the left side of it. So what would our X that we plug in to the formula based on the data on the screen? 5,000, fantastic. So we're just saying, hey, this is our starting point of where I'm going to begin to measure. So there's my 5,000. Our mean is what number? Fantastic, that's the 4,500 that was given to us in the story. Our standard deviation is the 500, right? And then we'll go ahead and put true because yes, we're adding up probabilities. There's no exact number in chapter 6 and on because there's no point in finding an exact precise point. We're interested more in measuring an area. So it's always going to be true. And that's why I have that true here. I'm not even going to ask you, is it cumulative? It just is always true. So only in chapter 5 do you have to worry about like false, but everything else in chapter 6 and on, it's always going to be true because you're just measuring a particular distance or width. So this is what we're going to do in Excel. So let's go ahead and pull up our Excel file. Bear with me while I try to make, it's okay. I'll just remember what it was. So here are the normal distribution formulas. And over on the right are different examples of when they would apply. So you can always look at these as a reminder of which ones apply. But also if you scroll to the bottom, I do remind you, right? Hey, false is for not cumulative. When it's a less than or equal to scenario, just use the formula, make sure it's true. And anytime we're doing a greater than or equal to, it's 1 minus our formula. And again, make sure it's true. So we're going to be using this formula right here, as we saw on the last screen, and we'll go ahead and type things in. So I'll type in equals 1 minus norm dot dist, and you can type it or you can click on it. We'll enter the x, which was the 5,000, comma, the mean of 4,500, comma, the standard deviation of 500, comma, and true, close parentheses. So give it a shot and be aware. So I know sometimes when we write in thousands, we add commas to make it pretty. Don't do that in Excel. That will only confuse it because it'll say, oh, there's too many commas, there's too many variables you're asking me to work with. So you'll notice here when I typed in my 5,000 and my 4,500, I did not put a comma to make it pretty. I just put the number, the numeric value. So what that says is that this space right here, the probability of getting more than 5,000 acres burned is that 0.15 and some change, so like around 15-ish percent. Let's do part B. Determine the probability that fewer than 4,000 acres is a greater or less than scenario. Less than, fantastic. And the clue was fewer, right? Fewer, less than. And when we write it as a math statement, make sure you got that arrow pointing to the left. That's a less than scenario. So if we draw it and we look, okay, I know where 4,000 is going to be. It's going to be right here. It's about 1 standard deviation away from my mean. So this time I'm interested in this part of the curve right here. And whenever we're doing a less than scenario, we just use the formula like as we see it. So there's our norm.dist. What's the x I'm going to plug in that I want to convert?
4,000.
4,000. Fantastic. And then everything else is the same, right? The mean's still 4,500. The standard deviation is still 500, and it's still true. So really, when we're working with these problems, the first thing we want to make sure we know is what kind of scenario it is to find the appropriate Excel formula, and then make sure we know what variables we're going to plug in. What's our X we're interested in solving for, and then everything else. And so the one we're working with now, and I'll color it blue, right? We're going to be using this less than scenario formula, norm.dist. So let's go ahead and type it in. Equals norm.dist, and I'll click it this time, save me some typing. Our x was the 4,000, comma, the mean is the 4,500 from the story. The standard deviation is the 500 from the story, comma, and then true. So I'm going to leave up my formula real quick so you can verify what you've typed matches what I've typed, and whenever you're ready, go ahead and hit enter. So we got 0.1587, which might feel weird because that was the answer to the last problem as well. So let's take a look visually. Why is the probability that fewer than 4,000 acres will get burned is the same as burning more than 5,000 acres? So it's bell-shaped, it's symmetrical. We are the same distance away on either side, right? We went down by 500 acres or 1 standard deviation in part B. And we also in part A went up by 1 standard deviation or 500 acres to the right. So we moved the same distance, and then we're interested in this similar or symmetrical, like mirror versions of that part of the tail of our bell, right? So if you've ever made a snowflake, right, you fold the paper in half, they would like cover each other. So they're symmetrical and they're balanced. And that's totally fine because that just happens to be the way we were set up in part A and part B. And what we're looking for is that probability, that area that we're interested in. In this case, less than 4,000 acres is represented by this area right here. Let's do part C. What's the probability that between 1,500 and 4,200 acres will be burned? So in this scenario, we're working with 2 X values that we need to find the probability in between. So there's the between, right? So we would write the probability that X is between 1,500 and 4,200. And so we're going to be using a very long formula here because we have to do it twice. So you can see norm.dist. We'll fill in those variables in a moment, and then subtract norm.dist and then the rest. So what we're really doing is, again, remember in Excel only knows how to read left to right. It doesn't know how to find exactly in between. So that's why we have to do a little bit of subtraction here. In that Excel is going to read from left up to one number and then left up to the other number. And then because they overlap, that's why we subtract to get rid of the part we don't care about. And so if it's helpful, right, if I imagine where 1500 and 4200 are, it's like here to here. And so we're going to be reading from left to right using Excel. And so what we want to do is you want to make sure you put the bigger X in first. Because if you subtract a small number and then a big number, you're going to end up with a negative, and we can't have negative probabilities. So the first X we'll plug in is that 4200, and everything else is still the same. And then the second X that we'll plug in that part of the formula is the smaller one, the 1500, and everything else is the same. We're going to be working with this very long formula in row 10. I'll color it green so it pops out at us. And let me make it a little bit bigger, because I think it's gonna, like, there we go. So go ahead and type in equals norm.dist. Okay. Then we'll go ahead and put in the bigger X first, so that's the 4200, comma. Our mean and standard deviation are the same as it always has been. So that's the 4500, comma, 500, comma, true. And now you want to be careful. You'll have to click on the other side of that parentheses or finish closing parentheses and type in minus. So you can see I had that formula and then I type in a minus and it's ready for more instruction. So that's when I'll go ahead and type in the next norm.dist. And let me do it from here, parentheses. Here we'll put in the 1500, comma, 4500, comma, 500, comma, and true. And then whenever we're ready, you can hit enter and let's see what happens. So let me show you. All right, let's do D, last but not least. In those years when more than 5,500 acres are burned, help is needed from Eastern Region fire teams. Determine the probability help will be needed in any year. So in this part D, all they've changed is the wording of the question. So they're asking a slightly different scenario and the purpose of getting help from other fire teams. So in this one, are we working with a greater or less than scenario? Greater than, right? Because that more. So again, we're just going to make sure we know our event of interest is X is greater than 5,500. And if I draw it on our curve, it's way out here, right? It's about 2 standard deviations out. And so we're interested in this little area right here. And again, what kind of Excel formula are we going to use? One minus. Fantastic. So I'm asking that because you'll see it in chapter 5, chapter 6, chapter 7, all throughout the rest of the course. And the sooner we remember that, the easier it will be, because at least you'll know which Excel formulas to pull out. So we're going to go ahead and use this one right here. Our X is that 5,500 and everything else is still the same. Now the nice thing is we had already worked with this formula earlier in part A. So you have 2 options, right? You could just click on the box where you had the formula previously, and you could just change out the X, save yourself some time with typing it all out. Or if you want that extra practice, just type like the whole thing, right? 1 minus norm.dist. In this case, our X is now the 5,500, and then the mean's 4,500, and the standard deviation is 500, and then true. So do what you're comfortable with. If you're just changing it out after you know you got the earlier parts correct, or if you want to start fresh from scratch, you can give it a shot. Check the chat real quick. Fantastic. Yep. 0.02275. So if we wanted to show more decimals, we can use the arrows to move it out. Again, just be aware of what the homework is asking for, how many decimals, 3 or 4. But if you ever get the right answer, but just the rounding is off, you can always message me using Ask My Instructor, and I'll just manually grade it and give you full credit. Then you don't have to redo it. Again, if we look at in terms of context, that 0.0228, if we think about it in terms of probability, very small, right? About 2.28% chance that we would need help from a fire team from the eastern region. Again, you can see it visually, right? These are very small space, and then the probability that we found was also very small. So